Very good morning, everyone. Can you guys hear me and see me? Let me know in the chat. Arad, session. Can you guys hear and see me? Thank you, Arad, for confirming. So we will wait for some moment. And meanwhile, how you guys are doing? Yeah, very good morning. Had breakfast, everyone, or just getting up, huh? Because it's Saturday morning. So just getting up, or oh, I can understand. Yes, that was my guess only. Just got up, huh? What about you, Shashan? Can you hear me, Shashan? I think Shashan can't hear me. Oh, yes, you can. Thank you. Thank you for confirming. So I was asking, you guys had breakfast or just got up like Arad? So, okay, I think Shashan is still trying to write or still thinking what to answer. But yeah, in meanwhile, so how was the yesterday's session, guys? So not yet. Okay. Yeah. So he also just got up, huh? So I think yes, in yesterday's session, we have started with understanding the BST questions. So one question, the second one which we have solved, that was very important. People have asked it in some of the bigger organizations, and that question could be asked again in some of the interviews. So it would be great if you guys can practice it in these weekends, that particular questions, and like once you will solve it and practice it with more examples, then I think in future you will not forget the logic about it, how the logic is working there. And apart from that, the first question was the top tree. So I think top tree, right view, top view, right view, left view. These are some of the like similar questions. So just practice these type of questions as well. Somewhere they were asking, you can easily answer it, right? And then after that, we started our new data structure, and that data structure was hash table, correct? So so while understanding about the hash table, I remember I have showed you like two examples. We started with book example, right? Where we started with like how can we efficiently store these books in our libraries so we can quickly access them. So we have seen that we started with trees and linked list, but somehow we are not able to store them properly there. Then we went into the array. Array was somehow it was good, but still in array, any of book searching was little difficult. So that's why we came with one more element or one more feature into our arrays, that was hash function. So then I told you hash table always has two things. One is hash function, second one was array, where we will store it, and hash function will tell us the place where we should store any of our information. Correct? And after that, we have seen once we are storing our informations, there might be some places, because everywhere we have a limited storage, right? And you know about the hashing part. In hashing, we can like, the definition of hashing is what? The definition is we will be giving them any length string, and the hashing function will provide us a fixed length alphanumeric string or key. The fixed length alphanumeric string is also known as the hash value, the checksum, and also known as message digest. In different contexts, it has been used as different names. So that has a fixed length. So that when we have a fixed length in somewhere, so we have seen some examples where collision can happen. correct? And I also told you the definition of collision. When the different input are applied to same hash function, different input are applied to same hash function, and that same hash function is giving same result for both of different inputs. That means collision is happening. Then I told you collision is not bad. We have lot of ways to handle collisions, right? And we have the main and popular one, we have seen two ways. First was named as separate chaining, and second one was the open addressing. So separate chaining, in the separate chaining we have seen that in the same index, like there are five index, 0 1 2 3 4 5, and at the fourth index collision is happening, right? So what I told you, at that index we will start creating a chain there, chain of element, right? Like at the same index we are going to keep multiple elements, correct? So that was the separate chaining one. And second one I told you, that was the linear probing. And in the linear probing there was some advanced, there was some more part of that, that was quadratic probing, and then the double hashing was also there. So the basic concept was, in the linear probing, whenever we are at any index we are seeing any of collision is happening, we will be looking for next free available space in the table. So that was the linear probing one. And for that we have seen that clustering was happening, because every elements are coming out the one side, which is not good, right? We need to like traverse everything to find out the next element. Then we went for quadratic probing, which was giving us, which was like jumping between elements little bit far, a little bit extra, rather than the linear probing. In linear we were going one by one, but in the quadratic we were jumping like a little bit. The formula you guys have seen, it was a square, right? So in the like at next is for finding out the next spot, you might be jumping three times or four times or nine times, like that. And same goes for double hashing also. They have given one formula. Based on that formula, we have to find out the next spot. Correct. So we have already seen all these things in our last class. Then I told you, yeah, then at the last when we were leaving, I have also showed you different hash functions, right? And I told you the one which we are using everywhere, that is the division method, where where we are just using our string and taking the mod value. And while taking the mod value, we have to clearly, I told you that the value of m, the value which we are dividing, it should be a prime number or a less division number, which gives us less division based on our size of table, correct? So that's I have to showed you. And after that there are, I showed you three four more methods, like mid square method, and digit folding method, right? And there was one more arithmetical, the last one, which was little longer as well. See, these methods I have shown you there, correct guys? So today what we are going to do, guys, first we will see, similar to hash table data structure, what we have in JavaScript. Because you know that, right? In JavaScript, they have just internally done, they have like, you have seen the example of stack, queue. We do not have any explicitly data structure for stack and queue. We just use array for them, correct? To implement the feature of stack and queue. In similar way, for hash table also, in similar way, see, in other language you might see hash table structure there in Java, or might be in other, but in JavaScript we have two things. And I think before 2000, before ES6 or ES 2015, there was only one thing which gives us the same functionality of hash table, that was object. In JavaScript, object are very similar to the hash table. You know, in hash table, if you guys remember, we have two things, key and the value. Key we create with the help of hash function, and then at that position we store the values. Am I right, guys? That was the hash table. In hash table we have only two things, key and value. In key, the key part we get it with the help of hash function. We pass our information which we want to save, then we got the key, and then we keep that key at that place, and they store the information. Similar way, in the object also we do that. In object, we have key and value and we store it. Correct. Second thing in JavaScript, which is very close to hash table, is called map. In JavaScript, map has also introduced, I think in ES6, once they have launched the new JavaScript version called ES6, ECMAScript 6. From there, they have introduced one more feature, which is map. So today we are going to see little bit example of them, so you guys can understand some method, a little bit differences also, and then we will move into implementation of hash table in our JavaScript. Okay, guys, are we good? From the last class, any questions you guys have, or can we continue? Can we continue now? I know you guys have already, because in lot of examples we have already seen so difference between hash map and hash table. So Ekta, hash map is a JavaScript part to implement hash table. Hash table, we can consider it's the parent data structure. It's a parent data structure. A hash table is it's available in Java, it's available in .NET, in everywhere. It's a data structure. Similar like stack. Stack is a data structure. Hash table is also a data structure. But with the help of hash map, we can use the feature of hash tables. That's the hash map. So hash map has been provided in the JavaScript. Okay, hash map has been provided in JavaScript, which gives the similar features which hash table is provided. So let's guys, I know object we already know a lot of object thing, but let me quickly show you uh, in the console, or here, yeah, we can see in the console. So JavaScript automatically do that. So see how we create an object in JavaScript. Very simple, right? So let's temp is go to object. So this is called object literal. Now you can see we have already created our object. Now if you want to provide a key, how we do that? We write like this. So like if I want to provide a key as an ID, this would be 1. Correct. So now if I want to print the temp, you can see guys, our hash table, you can consider it as a hash table also. So ID is our key and value is 1. Correct. In similar way, you can create multiple keys here. Name. Correct. Like that. Correct. So you see guys, with the help of these objects, you can create your hash table as well, right? So and now if you want to create a map, similar map we can also create. See, for map, they are giving a structure like this. We are already doing these things from so many questions. Correct. So now if we want to, like right now, map is already empty. So now if you want to set any values, so what we do, map dot set ID, comma, give the value 1. You can see ID is pointing out to 1. If you want to set the name also, map dot set name. And here we can give like, what is the name? I can write it Arpit only. You can see map has now 2 entries. Now, if you want to, in object, if you simply want to get the value, we just need to provide the key name and we'll get the value. You see, in object, if I do temp ID, we'll get the value. In map, how we do that? Map.get. Method name is get, and you can provide the ID and name, you will get the value. Okay. And for checking value in the map, you want to check that key exists or not. Like in the map, you want to check if a key exists or not. So you can check. They have different methods. Map.has, and you can pass the key name like name. Does it exist or not? We can check. It is telling us true. Let's give some wrong name here. It is giving false. So see guys, there are differences between map and object, and those differences are like that. See, in the map, it saves your data in ordered manner. in ordered manner. Like in the temp, like if we are providing one as a key, two as a key, it can save in any manner. Like it will not maintain your order, correct? But in the map, in what order you are inserting data, it will always maintain in that way. Always first entry will come first position, second entry will come after that, third entry will come after that. That's why uh, the map provides you this one extra feature, which is sometimes map is also called ordered object. Object is simple, it does not follow any order. In any order you can see the entries there, but in a map you will always get the ordered entries, right? And second difference is, guys, in object, I'm telling you those differences which matters. There are a lot of differences, but these differences little bit extra matter. And the second difference is, guys, object does not provide you any iterative. It does not provide you any iterative way. If you want to iterate any of the key, you need to use object dot keys, object dot values, these methods to convert your object into one iteration, and then you can iterate it. But in map, they provides it. They provide you iterative method. Let me open and show you. Already opened the map here, guys. You can see this is the map in the JavaScript. By the way, they also have the differences, which you guys can later read it. But what I mean by the iterative one, let me show you the what I mean by the iterative. Yeah, you can see directly in the form my map, we can directly iterate it, and they will provide you key value. This thing you cannot do with the help of object. In the object, you need to do for object dot entries, or object dot object dot keys, object dot values. You need to convert it, then you will get any iterative objects. But here you can directly do that. You can see these are all the methods which match provide. Entries is there in the for the iteration. For each is there. Directly you can apply for each. In object you can't apply directly for each. It will throw error. You can see it. If I do that temp dot for each, it will not work. See, it started coming as a undefined. We can't do that. But in the map, we have for each method. Map dot for each, we can simply do that. You can see it is returning a function to us. You see, at the bottom, it is returning function to us. So this is little bit differences. And so right now, let's read the differences which are mentioned here as well between the map and object. In JavaScript, yes, in object we can do serialization as well. Like you remember in the any object we can convert it into the string, and then we can again parse it. That feature we does not have in map. That's the drawback of map as well. We cannot do the stringify and parsing of our data. So JSON support, I would say that JSON support available in object, but JSON support does not available in map. That's the first difference where actually the object wins, correct? And iteration, already I told you. Performance better in scenarios involving frequent adding and removal of key value, not optimize. They're saying that if we have frequent deletion and insertion of a key, and that place map is better compared than using direct the object. Size, yes, because it is always iterate. Map always iterate into your entries, so that's why you have size property in the object. In this object, the temp, you can't get the size, how many entries it has. You can't get it. You have to do object dot keys and then count it the length of array. But map directly have a feature of size. It will directly provide you. See, map dot size equal to 2, but temp does not have anything like that. You can't get temp dot size. It will not provide you. We need to do object dot like this, object dot keys, and then count it, pass it the temp here, then this will return an array, then we have to do dot length, then we will get that. So these are some of the differences I want to show you guys, which we has, right? We can use map, we can use object, but right now after ES6, most of the time people has started using map because it provides you ordered entries, right? Always the entries which you will get an order, you can automatically maintain order there. So that's good about the hash map. That was the feature I feel it's little bit important, because see, whenever we are creating any object, at the end definitely we are going to iterate it. Lot of projects I did it where I create the object, at the end I need to iterate it. So for iteration in objects, little bit difficult. You need to convert it, and then you have to start the iteration on that. But with the help of map, iteration is very easy. That's why I most of the project I started using map there, because iteration is very easy, and it's also giving ordered as well. So sometimes if order matters for me in any of the scenario, that is well and good. So that's why I personally feel these two important differences between these two. But when, yes, you have seen that JSON.stringify, when I want to like send my data of object in somewhere as a response, at that place I think JSON simple object will make more sense. Okay, so let's see any other queries in meanwhile you have. That's what actually about the hash map and object. That's what I want to talk about little bit. So they just provide you the similarity which hash table has. Okay. Ekta is saying, is it necessary to give keys inside single slash double quotes in map? No, actually, in the map, actually, you can pass key as a string, you can pass number, you can pass functions as well. Let's see that. You can pass in many things as a key. There would be one place where we can pass multiple things. Key order, yeah, order already told you. Yeah, you can see the key types. Key can be any values, functions, object, any primitive as well. But in the object, you can only provide a string or symbol. In object, when we pass one as a string, it automatically internally convert it into a string in object. So that's but yeah, in the map you can provide anything. Any primitive could be there. How order entities here? So see, Joseph, in the map, what happened? Let me show you. Okay, guys. So let's see order part as well. So let's use a new object. Yeah, let temp one. Okay, then temp one. I am keeping two. Simply, let's keep it two here. Giving as a first, because this is the first entry I'm doing, right? This is the first entry I'm doing, so I'm writing it as a temp12. Then let's keep one there. This is the second entry which I'm doing. Correct. Let's see our temp1. You can see order has changed. First one is coming, then second is coming. But now let me show you in the map. Let map2 is equal to new map. Do the same thing there. Map.set, map2.set, key as a 2, and it is as a first. Then do map2.set again. Give as a 1 and then give it as a second, because this is the second entry I'm doing, right? And now if I print my map2, can you see that 2 is coming first, then 1 is coming? That's what the order I'm saying. In what order you are inserting in the map, order maintains. It maintains the order. But in object, it does not happen. In object, it can go into any of the orders. Okay. So we can use for each for iterating the object.keys in this also an array. Right? Yes, object.keys, object.values, object.entries. It provides us, it returns us array. And then we can do in array, we can do the iterations. Okay, guys. So this was little bit like very minor differences in JavaScript exactly. It's whatever we read till now, it was all about the JavaScript. Okay. In meanwhile, let's try to solve one problem with the JavaScript only, with this map or object. Let's solve two problems, one with map, one with object. Okay. And then we will jump into the next topic of it. So let's try to solve first problem from our today's topic. See guys, we will just merge both of the content today. So let's first solve this problem, and then we will go further into these things, right? We'll try to create a hash map there. So till now we have already read about the hash, like map versus object. And the second thing now we have to do, first we will solve two problems with the help of map and object, then we will come back to these slides. Okay guys, so let's solve these two problems quickly. These are very easy problems actually, and we will also see the uses of map little bit more in depth. That's why I'm just doing these problems, because we just read about the maps and objects. So let's do one problem as well. Okay, so see guys, this is first problem. We have given one input string. We have to find out the maximum occurring character in a string and print it. So you can see this is the string, which is the character which is maximum occurring, means it is coming again and again. So you can see A, it's coming one time, B, it's coming two times, F, E, and D, they are coming one time. So which character is the maximum occurring? It's the B. Correct, guys? Which character is the maximum occurring? It's the B. So that was our answer. In the second question, let's see the second question. W, it's coming two time. W is coming two time. Let's see about E. E is coming four time. F is coming one time. Q is coming two time. And that's all. So which character which is coming maximum time? It's a E, right? It's a E. So now I think it's we can solve this question very easy with the help of map, with the help of map very easily. So see guys, what we need to do here, let me come back to OneNote. We just like let's take the first example, A B B F E B, and let's create our new map. And you know that how to create a map, we just simply let map is equal to new map. You know that, or you can create object also, that's fine. And what we need to do guys, we just need to traverse this string and keep the frequency in our map, keep the frequency in map. See, first when we are at the ith position, which is A, so we'll keep, it is coming first time, so we'll keep this frequency as 1. Correct, we'll keep that frequency as 1. Now let's move our cursor to B. Let's move it here. Now our again B is coming first time, so let's keep the frequency as 1. Okay, let's move our B again. Let's move our cursor. Now B is here. Now B is coming second time, so the value of B will change. It will happen 2. Again we'll go for F. F will become 1. We'll go for E. It will become 1, and we'll go for D, and frequency will become 1. Correct? That's how our map will look like. Correct, guys? Anyone has any doubt? That's how our map will look like. Correct? And then we can simply traverse it. We already know the methods of traversing. Like this, for, like I already showed you right here, method of traversing, multiple ways to traverse it here. Let's see, any one of them we can use. We can use this one as well. We can use this one as well. We can use this one as well. See, here both things we are in the map. We can take both things, key as well, value in the same. Here we can only take key. Here we can only take values. Here we can also take my tab dot entries. So we'll use similar one, this one, simple one. We'll take our my map and we'll take out of key and value from there. So see, we'll first we'll simply do that. Key value of my map, which is map here. My map name is map here. Correct. And what we'll do, we'll take two variables here, max and answer, because what we need to print, we need to print the maximum occurring character. So we'll take first max as -1 and answer as a blank, and then we'll start iterating into this. So first we'll see A, first we'll say see the value wherever it is coming. So is it greater than max? Yes. So update the max here. So first we'll update our max with 1, like for this one. So max would be becoming 1 and answer will becoming A. Correct. Then we'll go for second one, this one. We'll see again answer. Is it greater than max? Yes. So update our max. Update max will become 2 and answer will become B. Again, let's look for B, F. Let's look for F. Is this greater than max? No. Let's skip it. Is E greater than max? No. Let's skip it. Is this one greater than max? No. So that will be our answer. Got it, guys? Was it difficult? It was easy question, right? At the end, you just need to traverse it and find out your max value from the map. Correct, guys? So let me show you the code as well quickly. You can see this is the code. This we have created a new map. Then we started the iteration and then we are checking. First, we are putting all the information into the map. So guys, just remember these things. You have to do these things so many places. So first I'm checking, is that string, is that character exist in the map? If yes, increase the value of it. So how we will increase it? First we will get the value of it and then we will do the temp plus 1. And if that character does not exist, just set that character as a 1. So that's what you can see. First time when A will come, first time when this A will come, it will not be existing in the map. So we will simply run this line, 23 line number. We'll keep that character as a and value as a 1. So you can see the first in the map dot set, first one is the key and second one is the object. Second one is the value. The first parameter is the key and second parameter is value. And we have the get method also where we pass our key. We have already talked about the hash method also. So that's in that way we will simply create our map. And once we created our map, we just simply checking the values. If we got some values which is greater than max, I will update my max and result. And at the end, we'll return our max and result. So guys, I want you guys to again, no, this part is not important. This part is important. How we are setting values in our map. Because while solving any of the problems, you are going to use a similar strategy. You're going to use a similar strategy. So just observe this code for some minutes and then we will move into the second question. And there we will use object. Very simply, we'll use object there. But yes, before that, just observe this thing. What we are doing here, we are checking it, how we are checking values in map, how we are setting values in map, how we are getting values from map. Everything is happening in these lines. Okay, now I'm coming back to chat. Initialize temp with 0. Why? Why we need to initialize temp with 0? And where is the temp? Yeah, it is here. Why we need to implement temp with 0? Who has asked? Joseph. See guys, that's what I'm saying. That's why I'm saying, understand, when we are coming into these lines, when we are coming into these lines, 21, 20, 20, 20 and 21, when we are coming into these lines, we are only coming when that key already exists in the map. And when will this happen? When will this happen? It will only happen, see, it will only happen when already any key exists in the map. When a key exists in the map, then only we will come into this line number 20 and line number 21 will only come when that key exists in the map. If that key exists in the map, it means that that key will definitely have value because we are setting it. You can see in the line number 21, when we are getting any new key which does not exist in the map, we are setting the value as a 1 there. So it means it will always have the value as 1. So why we need a temp 0? Understood, guys? Why we need a temp 0? Because see Joseph, and who was asking that question? Suraj or Hariharan. So guys, you have to understand these conditions first. When we are going into these conditions, if a key already exists, then we are going into these conditions. So if we are if that key already exists, we have to increment the value. Correct? That's what our logic is. If we got some duplicate values, means if we get the B second time, it means we need to increment this value. So that's why we are first getting the value of getting that value from the map and then we are incrementing it. Is it okay now? You guys understood? Hariharan, Suraj, and everyone understood? See guys, very important part. If you will not understand these lines, please tell me again. Because these lines I'm going to use in all the problems. So that's why very important for you guys. You have to understood these lines. How to find element, why we are doing this, everything. If you're not able to understand, let me know. I can again explain it. Because it's very important. If we initialize it with 0, might be wrong count. So see, what is the meaning of count there? What's the meaning of count? It means that element already we found it in our string. We already find A, that's why we are keeping it as a 1. Means A already has been seen. So that's why we are keeping the count. So why we will keep A as a 0? It doesn't make any sense. It means A value is 0. It means A does not, we have not find the A. That does not make, and that's not logical, right? That's why we are initializing all of entries with 1. It means they exist. Understood, Joseph? That count already exists. We can't use map A. Yes, I think we can't. Let me check it. This is not the way to access it, but let me try it in front of you guys. Let's see if we can access it. I don't know, it's JavaScript. At the end might be able to do that. But no, they have restricted it internally. They have restricted it. Somewhere they have internally restricted it. Sir, so the last line of code. These are the last lines. So in last line, we are just comparing the values of map and updating our max and result. You can see, we are just taking the benefit of map. We can directly iterate it. And once we are directly iterating it, we are taking keys and values and comparing our values with max. If we got any value which is greater than max, then we are updating our max, updating our result as well. Okay. Yeah. Now everyone is feeling confident, because I want you guys to feel. That's why I bring this question. I want you guys to feel confident here. Are we good? Yes. Suraj, Arad, Joseph, Hariharan, everyone. Yes. Great. So now let's second question also. We'll do that with the object, not with the map. Okay. Second question also. So we have given an array of strings, and we need to group the anagrams together and return them. So we have to, we have been given one array of strings, and in that array of string, anagram exists. So what we need to do, we have to group all those anagrams at one place and then return the answer from there. So what is the anagrams? Anagrams is two strings are known as an anagram of each other if they contain the same characters. One string is just a different rearrangement of other. So you can see anagrams are, guys, like there are three letters eat, like you can see the first example, eat. So anagrams of it would be same character, same number of character, but in different arrangement. Like A can come first. Like if I show you the example of anagram, like if it is a eat, so same anagram for it would be AET, TEA, TAE, right? And what else? ATE. So these all are anagrams of each. So that's what they're saying. Two strings are known as an anagram of each other if they contain the same character. You can see everywhere they contain the same characters. And one string is just a different rearrangement of other. So rearrangement, we're just doing in the letters, like A is coming after T, sometimes T, A is coming before T. That's what the anagrams is known as. And that's what you can see in the answer as well. So you can see, and then we need to combine these anagrams and return as an answer. So you can see eat, ATE, this is also similar. And what else? TEA, you can see, these are similar. Tan, nat, they are similar. Bat, there is nothing similar. There's no letter which is similar with the bat. So that's why you can see three group are coming here. Bat, nat, tan, 8, E, T. I hope everyone has understood the question with the examples and anagrams also. You guys have understood? Understood, guys? Yeah. So these are just anagrams. Same, the two string can be anagram when they have same number of characters, but arrangement of them is different. Okay. So guys, there we need to now just think about the logic. This logic is very easy because they are saying the first line, they contain the same characters. That's our hit. That's our hit. the, or we can say that's our, you know, the logic or the point where we can get the logic. What do we need to do? We just need to see, guys, just let me write this question here in the slide, in the OneNote. So our first string is ATE. Then we have what else? TEA. I'm just not taking it correctly, guys. Might be something wrong here. ATE, TEA, TAN, and then we have EAT. It's taking random, but yeah, from that array only. And NAT. Then we have BAT. Correct. So we have how many? Six small strings, right? And what they are saying, we need to combine the similar letters. So what will happen if we first sort each of a string? If we first sort each of a string, so see, after sorting A, T, E, it will look like this. See, A, E, and T. Correct? After sorting A, T, E, A, E, T, sort this one also. T, E, A. It will look like A, E, T again. Sort this one. A, N, T. Sort this one again. A, E, T. Sort this one also. A, N, T. Sort this one also. A, B, and T. Guys, can you see some similarities in strings? Yes, AET, AET, AET. These three are similar. ANT and ANT, this one is similar. And ABT, it does not have any other string. Guys, can you get getting some ideas now to create the logic for it? So we just need to, while we are iterating, so while we are iterating this particular array, we just need to sort it. After sort it, join this string and compare it. Like we'll first have one map. We'll have one map. So first sort it. So first sorting, after sorting, this will look like this: AET, AET, and take one array here. Take one array here. So insert first this entry only, ATE. Correct. Insert this one only. AET, or might be the original one. Might be the original one. Yeah, ATE. Insert the original one here. Then go for this one. Again sort it. If that sorted string exists in our object, then insert TEA here only. Now go for TAN. Sort it. We'll get ANT. It does not exist in the map or in the object. So create a new key and insert TAN at this place. Correct. Now let's go for EAT. Again, sort it and join it. We'll get AET, which already exists. So simply insert the original string, which is EAT. Now go for NAT. Sort it. We'll find it out ANT exists. Insert NAT at this place. Now go for BAT, which we got ABT. So simply insert it. And at the end, just return your values. At the end, just return your values. At the end, just return your values. So what we are doing, guys, we are sorting it out and joining it, and then we are checking is that key exists in our object. Then insert the original value in that key. If not exist, create a new key. Did you guys understood the logic? We'll say simply sort it, and after sorting, we'll compare it with the object. And if we find it out that key exists, we'll simply insert it. So let me show you the logic as well. This is very easy. And here we are not using map. Here we are simply using the object. That's what you can see. Simply using an object. Then we are simply going into our string array. We are splitting it, sorting it, joining it. You can see that's how we sort string in our JavaScript. Split it, sort it, join it. Once we join it, we got the letters. We are checking in our object. Is that object exist? If yes, push it. Push that string. If not, create that key and insert the string there. And at the end, just return the values. At the end, just return the values. Was it difficult, guys? So here values of array of yes. The value is a group of anagrams. Was it difficult, guys? This time I did not use map here. I'm just inserted the. I just use the object. Line number 20. So line number 20 is splitting, sorting, joining. You know, split in JavaScript. How you do the join? You first split it, sort it, join it. That's the methods of a string. It just split it, then sort it, then join it. 21 line. 21 line. Yeah, this one is that one. This one. If object, if like after sorting out ATE, it will look like this, AET. So if that AET exists in the object, you can see if this AET exists in the object, go for this condition, true condition. If not exists, go for this one, create that key. So that's why first time AET does not exist. So just we'll create AET and insert the original string ATE. You can see that's what we are doing. Object letters, this is the key, this is the value. And here that key already exists, so push next entry into that. That key already exists, push the next entry into that. Okay, Suraj? We can't sort by string.sort. Does that method exist? If that exists, we can directly do that. Let's see that. String.sort in JS. If that method exists, we can simply do that. Array.sort is there. Do we have for string as well? If yes, definitely we can do that. So no, I think it does not have, right? That's why we are splitting it. We are converting that string into array. That's why we are, if we have direct string method, then it's fine. Otherwise, you know that we are already, with the help of split, we are converting our string into array. What split does? Split convert our string into array, and then we are sorting it. Then we are again combining them with the method of join. Correct, guys? So these two questions were very easy, right? These were simple JavaScript like methods we were using, and we have somehow understood object and map as well. You can see in object very less code. We are not doing map or has, get, set. Those all things are not here. We are simply using object. That's why object is a little bit easy. But yeah, map has their own benefit, object has their own benefit. Are we good, guys, with these two questions? Now we will come back to our hash map. Now we'll come back to our hash map. Did you guys understood? First, let me know about these two questions. Any doubt? Anyone has any doubt? Yes. So at the end, we need to return the answer from function, right? Are we not returning it? Yeah. We are returning the values of object. Object.values. Okay, Hariharan? We're returning it. Sure, Ekta, yeah. See the keyboard. So we are first simply sorting our string. And once we sorted it out, we are checking in object in our map if that particular string after sorting out exists in the object. Already exists, push it. If not exists, create a new entry in object. That's what. At the end, we are returning the values. Yeah. But there is console of answer. That is why I ask. Yeah. So we are consoling it out our answer. Yeah, yeah. Guys, do you guys have any confusion in this question? Let me know. I thought this was very easy question. So that's, but if you guys have any confusion, just let me know. I can explain it again. Joseph, Arad, anyone? Hariharan says clear. Suraj. So, okay, run the code once, sure. You see, we got our answer. Eat, tea, ate, tan, nat, bat. All the anagrams are together. Understood, guys? Parag, is it clear now? Yes? Okay, so now let's come back to our previous class content, which was the implementation of HashMap, guys. So in the last class, as I told you, for implementing a simple hash table, we need two things. We need two things. Can anyone wants to tell what are those two things? For implementing a simple, do not think about the collision right now. Do not think about the collision. Just think about the simple hash table. Yes, array and hash function. So we need two things. So yes, array and hash function. Everyone correct? So let's create our class which has a hash function. Okay. I will open it as my reference if I miss anything, but yeah, let's create it. Let's create a new file. So index2.js, correct? So let's create our class hash table. Let's create our constructor, which is going to have two things, correct? So first, we are going to keep one array here, where we are going to store our information. And we can take a size, predefined size for this. Because you know that, right? As table, we have to create a small size. Otherwise, in JavaScript, it can, if I simply assign this as an array, it will never, it can, because array, in JavaScript, it's a dynamic memory. It allocates for array. But in other languages, it does not happen. And we have to define the size of array. So that's why for hash table, we always have a size. All hash table does not have like unlimited space. It does not. We can also take the size one, size as a for our hash table. Correct? Two parameters. So this is our array initialization. Now the second thing which we need, that's a hash function. So let's create a hash function here in the class. So our hash function, so in our class, we will be passing two things, key and value. As we are passing in object, similar as we are passing in our map. In our map, we are passing two things, right? While we are setting it, we are passing we are passing two things. So in our hash table, we will also pass two things, which will be key as a string and some value. Right now, we are only going with a string, key as a string. So first, this is our hash. We'll take a key here. We'll create the set method as well, which will be taking key and values. Correct. We will also create a get method, similar like has map, which we have read it there. We'll create a key here. Correct. These are the these are the two methods which we have used right now. We can also create the has as well, as method if you want. Otherwise, let's no not needed. So let's first create our has method. Okay, in the hash method, we will be passing our key. Oh, before that, let me also show you how will this look like. Hash, or let's see map also. Let's say it is map, new hash table. Correct? How will this look like? Map.set, we will be passing here a string. I'm saying you, we are going to pass a string there. So let's take it like Arpit or ID. Yeah, simple. Why Arpit? Let's take ID. Pass it as a value as a 1. Map.set. This will always be a string I'm taking. Name, take it as a Arpit. Right, guys? That's how our map was working, and that's what similar thing we are going to implement. Till now, are we good? Till now, are we good? We have not implemented any of the function. We just initialize all of our functions. Okay. Okay. So now, so once we are getting our keys, these ID and name, we need to get the position. And who will tell the position? Who will tell the position for these keys? Where we need to store this information? Who will tell that? Who will tell the position, this information where we need to store in our array? That will be our hash function. Yes. So let's now implement our hash function. So this is coming as a string. So now what we'll do, we'll take it's just one of method. I'm using very easy method, guys. It's not like you have to use this method only. You can create your own hash method as well. I'm simply using very easy method for this for creating a hash value. So I will use one variable hash as a 0. I will just traverse this whole string key dot length. I'm just traversing this whole string, and you know that I'm just adding this the char code value of it. So key dot char code add. What is the method? Let me check the method. What is the char code, or which gives us the char code, right? ASCII value of that char code of string in JS. It will give us number, right? Yeah, char code add. Let's quickly just see that. Yeah, so it is capital, it is coming as a 69. Yes. And if I provide you 2 here, it will be giving for, yeah. So char code add. Let's copy this method, char code add. It is giving us number, and we'll put it I here. Correct. So we are just traversing whole string, like ID will come. So ID will come. So for I, let's check it here quickly. ID will come, right? So for I, it would be 100. And for D, it would be, for D, it is showing not a number. Char code at 2. What happened? 1 minute, guys. Position in a string, yes. This is giving the char at, right? At that place, what is the char at? Yeah. No, we don't want that one. We want the char code at. Why it is not working? Char code at 1, it is giving 49. But when I take an ID, why it does not take this? It is giving 1, okay. What about the 2? Oh, it is giving not a number. Weird, huh? Is it start? Oh, sit. It starts from 0. So 0, it is 105. And for 1, yeah, it was 100. So yes, guys. So we will be getting 205. Understood? What this method is doing? In this hash value, we will be getting 205. So for I, it would be 105. And then for D, it would be 100. And then we will be getting 200 here. Then we will be getting 200 there. 205 there, and then we just need to simply yeah, so simply need to return hash mod this dot array dot length. Correct. With the, because this is our hash table size, so we just need to mod this value from there. Correct. Let me cross verify it with this code, guys. Also, yes, we have taken the hash table there, hash table dot length. Yeah, looks good. Correct. Guys, understood? You guys have understood that thing? Why we are using the char code at, and how we are calculating the hash value? Why we are doing the mod part? To get the indexes between 0 to 100 or 0 to 255, whatever the array of size is. That's why we are doing it doing these things. And I think, yes, it would be better. Okay, let's find it. This is array. Let's keep the same name. So Joseph, we are passing our key. So you can see it start from here. When we are setting it, we are passing our ID and value. So for storing these informations, ID comma 1, we need a place in array. We need a place in array. Correct? We need a place in array. So for finding out the place in array, we need a hash value. Correct? We need a hash value from the hash function. Hash function is only going to provide it. First, you guys have understood this thing? Hash function is going to provide us the position where we are going to store it. Correct? So for that, what I did in my hash function, I use this method where what I did, I just traverse this whole key because this key is coming in a string. So we just traverse this now whole string and we just converted it into a number. And how we will get the number? With the help of char code add, because char code add provide a number for any of the letters. In a string, if letter exists, it provides us number. So we just added it, and then at the end we did the mod with the length of our array, with the length of our total array. So it will provide some position in this array where we are going to store it. And always this hash will be same for ID. Whenever how many times you pass the ID, it will always be same, because char code at will always be giving us you same value. For I 105 is always the value will be same. 100 always will be same. So that's why you will always get the same hash for ID. And that was the property of hash function also. Whenever you are passing any of the string into hash function, always we should generate the same hash value. Correct? So that's what happening here. Now you guys have understood char code at why we are doing the mod and all those things. Arad, Parag, now understood? Yeah, if 2 key T and 8 is there, different values. If two key T and 8 is there, T and 8, yes. So for T and 8, yeah, it will be same. It will be same, not different. Yes. For T and 8, it will be same. Correct, because they are the ASCII values. Yes. This is the collision case. Parag, this is the collision case. ASCII of I plus D. We are doing this ASCII of I plus D. Yes. Correct. ASCII of I plus ASCII of D. Correct. Correct. That's what we are doing. And then we are whatever the addition is coming, we are bringing it inside our range, which is 100, which is 255. The array range is 255. So that's why we are doing the mod. So bringing that value inside our range. So Parag, that is collision case. We'll talk about the collision case. Okay, in the collision case, we'll handle it. I told you, right? Collision is not a problem. Collision will handle it. Have you understood now, guys? Are we good with this hash method? Any confusion here? Let me know. We can move forward then. It was very easy hash function, guys. It's very easy. It can be easily cracked. Yes. A is equal to 97, 98, AB is equal to 195, and CB is equal to 195. A is equal to 97, okay. B is equal to 98. And if you add AB, 195, okay. For CB, it should be 196, right? Where you will add CB, it would be, I think, you will add 98 and 99. It would be 197 for CB, right, Likit? For CB, it will be 197. Yeah, no problem. So guys, let's see. Let's move forward. So we see. I am again telling you, this is not the very mature hash function. I'm just telling you very easy match. Where this is very easy hash functions. There are very complicated hash function already available in internet, but I'm just making it very smaller and very easy to understand. Okay, so there would be definitely a lot of collision will happen. Okay, so now let's move forward into our set method. So what is the first thing we need to do? We need to pass our key into the hash, so which can provide us the index. So that's what the first thing we'll do, this dot underscore hash and pass our key. and which will give us the index. At this index, we need to insert it. Let index. And at this index, we just need to simply insert our element. So this dot array index and keep the same key and value together and increase our size. This dot size plus plus. See guys, I'm not telling right now about the collision. Again, I'm telling you, this is not the collision case. That's what the simple code. And when we are talking about the get, simply just return. So first, no. For key for this also, first go for hash and get the index value for that. Get the index value for that, and then simply return this dot array and that index. That index. This is simple, guys. This is very simple, right? That's what the set and get are. But do d is equal to 190, 100, 198, 100, what about this? Again, Likhit, I'm again telling again and again the same thing. These are collision things and we will handle it. And right now we are not implementing the collision scenario. Everyone, I'm not handling right now the collision things. Okay, this is the collision part which you told Likhit. So definitely I'm saying, right, collision will happen. And again, collision is not a problem. We will handle it. Okay. So guys, see here. So we have implemented very easy methods of set and get. Correct. Which are, let me pass it and let me show you the values. Map.get. We'll do the name here. If you do the map.get ID, we are going to get our answers. Yes. So let's and put it in the console so we can see them as well. Put them in the console as well so we can see their answer as well. Console.log map.get console.log map.get. Correct. Let's see the answer as well, how they look like. So node as table and index2 .js. You can see guys, we have set it id in one. We are getting when we are printing out name, we are getting both things, name and Arpit. When we are looking for id, we are getting both things. That's what the simple thing, right? It's not collision is not happening here anywhere. I'm just understanding right now collision is not happening. Are we good with these logic, guys? Are we good with that? If you want to delete it, that's also very simple. If you want to delete any of the key, we can create a remove method as well. We will pass our key. But before that, are we understood get and set? It was very easy, right? Pass your, but see, it is easy, but you need to understand the logic, like how the flow is running. Every time you are passing any key, you need to pass that key to hash function. Like whatever we discuss, can we visualize it with the code as well? That's what I want to explain it first. I was telling you, right? Whenever any string is coming, you will pass that key into hash function. Then you find it out the position, and at that position you are keeping your information in array. That's what I want to visualize it here, and that's what happening here also. This is our hash function, which is returning simple hash value, and in that hash position we are keeping that value, key and value, both together as an array. And then at the end we are returning that index. Simple array manipulation. So now are we good? If you want to remove also. So first again, same, find out the key or index, like yeah, index. Let's find out the index. How we'll find it out? With the help of hash only. Everything will going through the hash function. And that's what from the yesterday we are talking about, how important hash function is. Correct? And that's what we are seeing it today as well. How important our hash function is. Now we got the index. Correct? So let's check if at that index any element exists or not. If at that index any element exists, we will simply make it empty like this, and then will reduce the size also. Size minus minus. And then return true or something like that. Return true. And if it does not exist, we can simply return false here. It means you are looking for some wrong element. Return false, which will tell us you have not deleted anything. Correct? Let me compare it with the one more condition is there, I think. Ah, yeah, we can check the length as well. Like, see, that element exists, or yeah, if that element, that index exists, because in that index, empty array could also be there, right? So empty array could also make this condition true. So that's why we are checking one more thing. If that, if at that position, index has any length as well or not. Yeah, these two conditions will make our solution perfect. See why we did this line? Because at that index, empty array could also be there, and that empty array will make this if true. But you can see empty arrays should not be our solution. We cannot delete an empty array, so that's where we are checking that array, that at that index something should be there. Then if something would be there, then length would be 1, not 0. Then we will go inside this condition. So let me now run it. So now do the console.log and remove ID key. It should return us true. It should return us true. And then if I do one more console, with the key, something like random name, like this, it should give us false because that key does not exist. Let's see that our output. Some error is there. Let's see ID. It should be a string. Sorry for that. I already told you, right? It should be, we are considering it as a string. You can see true and false because ID exists, so we have deleted it. Now if we want to see the output again of for ID, I think it should come blank. Let's see that. Yeah, you see output for ID is coming as a blank because that's what we set it. It's as a blank. Got it, guys? How the deletion is happening? Simple array operations, nothing else. Nothing specific to the one. Nothing specific to hash table. Simple array operations. Correct. Now we will talk about the collision. Till now, are we good, guys? Roll up size, we can just simply tell at the later the roll up size. You can see here also we use the size, right? We have not used it anywhere. Yeah, we'll see the size, roll up size. But yeah, we can simply tell, in the map method, we have the size method, how many element already exist right now in our map. With the help of size, we can understand. Same here in this hash table, we can use that size property to understand the size. You can, let me show you. Map dot size. Yes, this dot size. Yeah, let's see. See, one element is there. Understood, Parag? The role of size, same like the map method. Map has the size method or property. Sorry, this is not the method. This is a property. Size is property. Can you show the code once again? Sure, Arab. This is very easy code actually. It just we are doing some array manipulations, and I want to show you like how the hash function which we are talking from the yesterday looks like. How the any hash table looks like. Are we good now, guys? Yeah. So now let's talk about the collision scenarios. So what is so and we are going to use the chaining method. We are going to use chaining method. Correct? So now whenever we close it, collision will happen. What we need to do at that place, we need to add the same element again in that position. We can use the linked list also. We can use the array as well. We can go with both ways. We can go with both ways. We can go with both ways. We can add an array also, right? We can add in linked list as well. Whatever. See, we are starting with arrays, so we'll go with arrays first, and then I will show you the linked list as well. Okay, understood, guys? See, let me visualize it to you guys also. Let me visualize it. So right now, I'm visualizing you into array as well and in the hash table also. Okay, so this is our array. Just consider 0 position, 1 position, 2 position, third and fourth. Same in the hash table. 0, 1, 2, 3 and 4. Correct? This is our key. Or this is our uh, values. Correct? So now at the second position, right now, what we are doing, we are putting two things here, key and value. Correct? So like ID and 1. Correct? ID and 1. That's what we are putting at this position. Correct? That's what we are doing at the, it will look like here also. At this position, ID comma 1 is there. Right, guys? Let's insert it at the 0th position, something also. Like here, I'm just keeping name, just randomly, name, comma, Arpit. Correct? At the 0 position, we can keep here also, name, comma, Arpit. That's what we are doing till now. Are we good? That's how the visualization is happening. Anyone has any doubt? First, let me know. You guys visualize it or not? The way which I have represented it here, are you guys able to visualize it or not? Everyone, yes. Now let's talk about the collision thing. What will happen in collision? So now at the second position, I got the third string, which is like city. Somehow city, which is like Kanpur, this also is going to point to second position. That's what the collision is. Different input passing to same function, giving the same value. This is the collision, right? That's what you guys are concerned about. When what will happen in the collision? In that place, what we will do? We will insert at the same place city as well. That's what we are going to do, guys. We'll take it as a big array and second entry will be inserted here. Similar way, third time anything is coming and collision is happening, we'll insert the third entry here. Same goes for other indexes as well. This will happen. So I was telling you in the last day, this can be converted into array, this can be written into the linked list, anything. So right now I'm using simple array, so we can just simply insert the next set of entries into the same array. Otherwise, we can go for linked list as well. Yes, so an array of arrays. Or we can go for linked list as well. Anything we can, anywhere we can go. In linked list, what will happen? In the same position. In the same position, in linked list, guys, what will happen? In the same position, first we will be having ID comma 1. And then next node will be here, which would be city comma key, Kanpur. Then next node will be there. Correct? That's the linked list one. Did you guys now able to visualize it? What will happen in the collision one? We can go with both approaches, with arrays and linked list. I have both the code in the logic. You see, this is the hash table with linked list. I implemented the same method with linked list as well. And here in the collision one, I implemented it with array as well. So in the code, we have both methods. So I will show you quickly both of the methods. Let's start with array first. But yes, before that, visualization is important here. Did you guys visualize it, both scenarios? Not both scenarios, just one scenario, but two different mechanisms to implement it. Did you guys are able to understood? Can you repeat this collision? Sure, Vishal. So Vishal, did you understood first thing that how the collision will happen? You know that, right? What I told, at the second position, ID comma 1 was there. And then we inserted third entry, which was city, and city name was Kanpur. Somehow the hash value of city also came 2. After when we calculated the hash value for city, it also given us 2. So this is the collision happened. Because why we are saying collision happened? Because already at second position something already exists. Correct? That's a collision. So when something already exists there, so what we need to do? We have to do chaining. We have to do chaining. That's what the first one we are right now discussing. We have to handle that collision. We have to do chaining. So for chaining, I'm saying there are two implementation. One is with the help of arrays, and second one is with the help of linked list. So if we are going with the help of arrays, let's draw there. It's the array way, and here it's the linked list way. So in the array way, what am they saying? While we are in starting, we will be take bigger array, and inside it we will be inserting id comma 1. Then the next element would be city comma k, like this. Then the next element will come, like consider one more is coming here, which is A's. Somehow that A's is also our hash function. See, this depends on our hash function. Somehow our hash function again pointing it to the 2. So what will happen? Age will come here as a third entry in the array. That's how our array will look like. And when we will traversing it, we will be also looking for these keys. Like when somebody is asking for get age, will be again age will how will we get a get also? Get will also work in similar way. Once we will ask for age, it will give us 2. Will we go for second index? Then we will traverse one more time into this one, in this array, and we'll find it out wherever age matches. We'll say this is the output there. Now for linked list, what will happen? We will be creating a linked list here, which will be id comma 1, then next address. In starting, it will be pointing out to null. First node hai. Ab the next node, once the next node will come, like the city, we will be doing this. City k, again it is pointing out to null. Again age is coming. Age is coming, so it will look like this. Age 2 and pointing out to null. These are the two implementation. Are we good, Vishal? Yes. So now let's see the code for array first. Okay. And we'll understand the code of array. But yes, this visualization is important. This visualization is important. Okay. Now let's go into our code for the collision one. So you can see nothing changes here because it's the array only. We are going to take the hash table as the array size. Same here, same array size here. Same, we have a hash function which is going to give us the value. Now the changes is here. Now changes is here. So this is the similar like earlier. Like earlier, you can see once we have our index, and if that index does not match, it means collision does not happen. You can see this one is this dot hash table index. It means if that index has any entry, but or if does not, it means collision does not happen. If collision does not happen, just in the bigger array, in that bigger array, push the key and value. Like first time, let me erase it. Let me do it from the starting. Let me do it from the starting, the array ways. So right now, let's consider id and 1 is coming. id comma 1 is coming, which is pointing out to 2. Because right now, nothing exists. Right? Right now, nothing exists here. So what will happen? What I'm saying, what I'm doing, I'm creating first the bigger array, which you can see here. This is the line. I'm creating the bigger array at that index. And then in that index, I am pushing key and value. And then I will push in this key and value, which is id comma 1. id comma 1. Correct? That's what I did. You can see. And then I'm increasing my table size. Okay. Are we good with that? Now, if the index exists, now let's consider city comma k is coming. City comma k is coming, which is also again pointing out to 2. Right? Which is again pointing out to 2. So what I'm doing, I will be going into now inside this condition. Now I will be going into this condition where hash table exists. So now what I'm doing, I am just at that index. You can see at that index, I'm just iterating it at that index. You can see at that index, I'm just iterating this whole array, and then I am first I am finding out if that key already exists. The key which we are looking, city, if it already exists, so we just need to update the value. If city already exists, if I'm saying city already exists here with the value of Kanpur, but somebody is updating city as a Delhi, so I just need to update the Delhi here, right? So that's why this line is working there. If this hash table index 10 is equal to key, if already matching, then just update the value. If not, then you can see at that index push the next key and value. If city does not exist, if city already does not exist, then simply insert the city comma k. That's what the code is doing, guys. Let me open this code for some seconds so you guys can see it. And let me put the charger in meanwhile. You guys see this code and let me know where you guys is stuck. You can see that's how we access the 2D array. This is the first index. This index will point out to this whole array, this whole big array. This index will point out. Then inside this index, we again two arrays. For accessing them, we need I0, I1. This is simple array operations, guys. Okay, now let me come back to chat and let me see where you guys face problem. So can you please pay? See, already this code is available in GitHub Ekta in my repo in the master branch. So it would be great if you can copy from there. If part, explain again, sir. If part. This one, right? This whole rhymes. Line number 18 to 25, right? Yeah. So, Hariharan, see, our loop will come when we already have one entry. When we already have one entry in that index, at the second index, we already have that entry. Then only we will go into the line number. We'll go into the line number 18. Did you understood first this part? When we are going into the line number 19. Yes, Joseph. We update that value if we key matches. Yes, yes. Yes, Joseph. For a question, for answer to your question, it's yes. Harian, did you understood this thing? When we will go into that, so you have understood that thing. So now, for city, this is the entry which we want to insert it here. So what we are doing here, first we are checking, is the city already exists in this array? If the city already exists in the array, if that city already exists in the array, just update the value. If not, insert whole key and value together. So for the not part, this is the code. For the not part, this is the code. If city does not exist, simply in that index push key and value. Simply in that index push key and value. And this part of code is just doing the checking. If key already exists in that inside the array, then update the value. Then update the value. And you can see in an array, in this array, this is a 0 position, this is the 1. 0 will always have key, 1 as always has value. So that's why you guys, if you guys are confused with 0 and 1, why 0 and 1 is there? So that's why the reason 0 and 1 is there. We are checking key in this condition, line number 19, then we are updating the values for that key. And then we are simply returning from there. Because we do not want to insert it then. We simply want to return it because key already exists. Got it, Hariharan? We update and we why we will push it, Joseph? That key already exists. We won't push it. That's what the return is there, right? Joseph, this line number 21 return. If the key already exists, why we will push it? We'll just update the value. If city already exists, we'll just update the value from Kanpur to Delhi. We will not insert, we will not push it. Understood, Joseph? We'll simply update it. If that key does not exist, then we will push it. Previous key value should be present, like city Kanpur. Yes, if that key present, then we will simply update Kanpur to Delhi. We'll not push next city and next city as Delhi. Next entry will not push it. We'll simply update it. City to Kanpur, city to Delhi. Yes, Kanpur is gone. Kanpur is gone. Yes, we'll simply update that. That's what we do in the object also, right? You remember in object, in the same value, if you provide the different, it will override it. That's what. Sir, line number 25. Okay. Line number 25. Yeah. So this one is the second scenario. If the key does not exist, if city K does not exist here, we will simply push it. If city K does not exist, we will simply push it. City, comma Kanpur. Simply create a new entry in the array. Understood? Same index, but different. Yeah, yes. Yeah. See, index is this 2. Index is this 2. And I is, see guys, there are 3 things you can see. See, there are 3 things: index, I, and 0. So index is this value. Index is this 2. I is this. I is equal to 0, I is equal to 1 inside the array. And 0, 1, this one, 0, comma 1 inside this array. We have 2D arrays, right? And not 2D array actually. We have 3 arrays here. This is the first array. The main one, hash table one. Then we have again one more array inside it. Then we have one more array inside it, id comma 1 and city comma k. So these many arrays are there. That's why 3 things we are accessing: index, I0. This index is this one, the first array index. Then I loop is running on this whole array where we are going to store, because this is the chaining part. Here the chaining is happening. And then inside that we have city in K as well. Understood, guys? 2D only. We can say, is it 2D? Yeah, 2D is there. 2-dimensional is definitely there, but I'm considering this also can can keep multiple values. So one more array is there. So one more array is there which can define the multi-dimensional. Looks like it's 3D, right? Okay, let's come back to it. Let's come back to it. Whatever dimension it is, we can simply access it through the for loop. Whatever dimension it is. Okay. So now let's go for the get scenario. What will happen in get also? So first we will find out the index, which is our target or index. Once we find it out, we'll do the same thing which we were doing for updating. You know that for updating a key, we were trying to find the key there as well. Same for here as well. We'll simply find it out and return that particular element. Return that particular key. And if we do not find that, we simply return undefined. That key does not exist in the hash table. Guys, see this part of code also. Similar to set code, guys. You see, this part of code and this part of code is similar. It just, once we find it out the key, we are returning the answer. Earlier, we were updating the value at the one index, but here we are simply returning the value. Easy, right? Easy. Can we move into the next one? Remove. Can we move into the remove one? Let's quickly see the remove one as well. Get is done, set is done. Let's go for the remove as well. So for the remove, same checks, hash table index and hash table index dot length. And this time, because we have one more array inside it, so we will be first looking for the key. Once we find it out the key, we will be doing the splice. Because you know from the what splice does? Splice method does. This is the array method. Splice. You know, if there are like 1, 2, 3, 4, 5. If there are 5 elements in an array, and if array.splice take 3 parameters actually. First, I think it takes the starting position. Yeah, starting position. Second, it take how many element. I remembered it earlier. And what to insert. Yeah, insert value, something like that. Third parameter. So if we are using two parameters only, array dot splice 1 comma 1. If this is the 1 comma 1, so it means go for the first position. So in the array we have positions like this 0, 1, 2, 3, 4. Go for the first position, remove the one element. Remove how many elements? Remove the one element. So after doing this operation, your array will look like this 1 comma 3 comma 4 comma 5. It will be removed one position. If we put 2 here, if we do array dot splice 1 comma 2 in the same array, in this array, guys, in the same array, if I are doing this one, so it will return as 1 comma 4 comma 5. From that position, it will remove two elements and insert. And if we provide three things, so I think after insertion, it just inserts something there. I have to check this thing. If we provide three things, array dot splice 1 comma 1 comma 9. So first it will go into the first position. It will remove the two. I'm still taking the same array, guys. It's still taking the same array. It will remove it, and then I think it will insert the 9 there. So output will be like this: 1, 9, 3, 4, 5. I need to check this thing, the last thing. But yeah, I'm sure about this thing. Definitely this one is correct. I will check this thing very quickly. Just give me 1 minute. I will check it. Yeah, it will insert at this. Yes, it will insert at the removed place. Correct. Yeah, so let's quickly check it. No problem. Let's quickly check it. Array splice method. We can use array slice method also. It's not like we have to only use the array dot splice. We can use the array dot slice method as well. You can see. So 2 comma 0, it's saying second position. It is not deleting anything. It's just inserting lemon and kiwi there. So let me show you the output of it. You see, earlier it was banana, orange, apple, and mango. But after the operation of fruit, it looks like after orange, lemon, and kiwi got also added, and apple, comma mango. Apple, mango is already there. So from the second position, these two new elements have been added, and we can delete this. If we will provide some numbers here, it will delete as well. So that's what the splice method is. So that's what the similar thing is happening here as well. Once we reach to the index, we find out the key. From that index, remove the one element, because only one entry we need to remove. We'll remove it and reduce the table size to minus minus. And then we are returning true. Understood, guys? That's what we'll do in the remove as well. We have to simply remove it. You guys can do it later as well. Once you have this, but yeah, you should have ideas what to do. You need to reach to the key, and then you have to remove it. You can use slice method as well. And because why we see earlier we were simply keeping the empty array at that place. We can't keep the empty array at that place, right? In this place, because we have multiple arrays there, right? See, we will be having multiple arrays like this. Like here it be city will be there, ID will be there, age will be there. You want to delete age, so delete this element, right? So that's what I'm doing. I'm going to this position. This is I is equal to 0. This is I is equal to 1. I is equal to 2. So once I reaches this 2, my key is matching. You see, that's what I'm doing. I'm running my for loop. Once my key is matching, I'm doing I comma 1. So at that place, do the I comma 1. So from that place, just remove that entry. From that array, that entry will be removed. Understood, everyone? What the splice is doing in the remove method? Yeah. Now let's quick. Do you guys a break is needed? Okay, let's go for the break then. Then we will quickly see one more thing here. Okay, guys, so let's go for break. So it's right now 11:36. So let's come back at 11:41. Okay, let's come back at 11:41. Oh yeah, 11:51. You guys are good at math, yeah. I am a little bit weak. Go for 11:51. Yeah. Yeah, no. Go for 11:51. Yeah. Is everyone back now? Great. What about others? Vishal is also back. Okay, guys. So I think now we have already completed the 11:51. Okay. So now guys, let's talk about one more thing, which is our next topic from our previous class, which is called load factor and rehashing. Which is called load factor and rehashing. What is this load factor and rehashing? Everyone is back, right? It's already 11:51, so I'm hoping like everyone is back. Yeah. Okay. Okay, so now I was going to talk about load factor and rehashing. So guys, rehashing, it's another way, it's one more way actually we can say to handle our collision, to handle our collision. But before understanding the rehashing, just understand what is load factor. If you guys like doing the BTech in computer science, you definitely got some of the questions in your exams as well to calculate the load factor. Calculate the load factor. In general terms, load factor is or the load is like how much your hash table can handle data, how much maximum data, how much maximum data it can handle without going for collision, how much maximum your hash table can handle without going for collision. So they say it, for calculating the load factor, just take total number of element which exist in your hash table at any index. At any index, total number of not like at each index, total number of element divide by size of table. That's the formula to calculate the load factor. Correct. So let's see for calculating the load factor. So if table size is 5, table size is 5. So like this will look like this: 0, 1, 2, 3, 4. Correct? Our table will look like this, where we have these are the keys. Let me raise it. These are the keys, and here we will have the values. Correct? So now at this place, if we have one element, at this place one, if we have one element, if this place we have one element, so what would be the load factor? So load factor would be total number of elements, total number of elements divide by total size. So it would be 3 divided by 5, which would come near to 0.6. Am I right? Correct. And guys, they always says that always we should keep our load factor less than 1. Always we should keep our load factor less than 1. And once we are reaching to the level of 1, we should do rehashing. We should do rehashing. Okay. See guys, if you have a smaller size, if all the, if I fill all the indexes, I'm just considering my hash function is that much smart, which is whenever any new entry is coming, it is just inserting it at each key, not doing collision till now. So you can see if we calculate the load factor right now, it will be 5 divided by 5 will be equal to 1. Now automatically the next key which will come, definitely collision will happen. There is no other way that we can reduce the collision. Is it right or not? You guys tell me. If we have 4 entry and I am 5 entries in our hash table, and I am saying that my hash function is that much smart, it is keeping all the entries in different keys. It is uniformly distributing keys. It's not doing any collision. But after completing the 5 entries, I am saying if I am going to enter in my sixth entry, it is definitely going to be collision. Correct or not? Correct or not? It is definitely going to make the collision. So for that, guys, they have told that always whenever you are creating your hash table, you should have some value for load factor, and once you are exceeding that load factor value, you should do the rehashing. And what is the meaning of rehashing? Just double the size of this array, just double the size of this table. So right now it is 5, just make your table size as 10, and then you will be having these much spaces: 3, 4, 5, 6, 7, 8, and 9. And once you will do the rehashing, all the elements which are saved here, they will automatically reassigned here with different hash values. So that's why we are saying rehashing. Because earlier, how we calculate the hash value? We do this, right? Key mod table size. Key mod table size. Correct? That's how we calculate the hash values. But now the table size has changed. So these hash value will also change. Right? Once the table size will change, hash value will also change. So that's why that term rehashing comes. Understood, guys? So ideally, they are saying load factor should be 0.75. For your hash table, if you will read the general terms, they are saying load factor should be maximum 0.75. And if your load factor is exceeding to 0.75, directly do the rehashing. Then you will get very less chances to collision. Yes, the simple ideas with fascinating names. Yes. But load factor, actually, it's very common term for calculating a load for any data structure, not only to hash table. For other data structure, they also do that. But yeah, here it make more sense in load factor, and then do the rehashing. So we are just increasing the size and calculating the values of existing entries again with the increased size. So that's what, guys, about the load factor and rehashing. And ideally, they say that we should always consider load factor as a 0.75. We can reduce it also. If you will reduce it, it's better. You will see how much less you have your load factor, that much less collision will happen. Arat, rehashing means whatever already have with the table size 5. So see, this is key 2, which somehow got hash value as a 0. So now here we have 5. If we have 2. Here we store the value 2 with the hash value 0. Here we have 5 with the hash value 1. Somehow here 17, here 18, here 19. Correct? These are the hash value for those values. Correct? Now, once we increased our size, this value will be changed, right? This value will be at different positions now. Might be this 2 can come now at the 4th position. This 19 can come at 0 position. Because why? Why will this happen? Because now table size is changing. And our formula is this one, right? Key mod table size. Key mod table size. So once the table size is changing, definitely. So see, let's take very simple example. If I'm entering 20, and if my table size is 5, so 20 mod 5, 4. Fourth position will store the 20. But if my table size is 10, so it would be 0 position. At 0 position, 20 will be stored. That's what the rehashing is happening. For same number, rehashing is happening. Now you got the meaning of rehashing with this example. For the same number, rehashing is happening. And why we are doing the rehashing? Because our load factor is increasing. Our load factor is increasing. And I told you, when the load factor is increasing, definitely the chances of collision will increase. What if the 0 positions already has value? So definitely we'll go for the next value, or we will do the chaining. See, Hariharan or everyone, we cannot remove collision fully. Definitely collision will be there. But see, I told you this thing. If I'm saying these 5 elements are there, already everything has been properly distributed, all the key are properly distributed. Now if we have the sixth element, it makes sense, right? Automatically collision will happen. Correct? If we have five elements, five spaces in hash table, and all five places are filled, if we are going to fill the sixth element there, automatically collision will happen. But like you can't remove it, collision will definitely happen there. So that's why what we need to do smartly, we need to increase that table size. So there are some chances we can reduce the collision. No, no, no. No, no, guys. Nothing like that. I am saying we are trying to reduce the collision. See, I think Hariharan, you have not seen the first scenario. First scenario, I told you 0, 1, 2, 3, 4. If these five positions are already filled with some element, now you tell me next element is coming. Next element is coming. Where you will store? Definitely collision will happen. So now the advanced step you are taking, advanced step. I'm not saying you cannot do the collision. Collision will happen. I'm not saying collision will never happen. Collision will happen. But as an advanced step, what we'll do, we'll increase the size of this table. There might be some chances. There might be some chances we can reduce the collision. And that's what I showed you, that there might be chances like after 4, next element could be at the fifth position. Might be. It's like, see, same example. Let's see same example here. Like earlier, we have 24, right? By the way, yeah. Let's take, see, let me tell you one more example. 1 minute. Let's take 24, 21, 22, 23, and 20, and 34 and 33. Okay, this is our examples we are taking. Correct. Now let's take the table size as 5. Okay, 0, 1, 2, 3, 4. Okay. Now do what? Let's do that key mod table size. So for 4, 24 will be stored here, 21 will be stored here, 22 will be stored here, 23 will be stored here, 20 will be stored here. Correct, guys? Now all of our table is filled. Already all of our table is filled. Now for 34, we know that definitely it is going to be collide. Definitely it is going to be collide. Am I right or not? Definitely 34 is going to be collide. So for that, I am saying we will be doing the rehashing. Before inserting 34, first do the rehashing. There might be some chances, I'm not saying definitely it will happen. There might be some chances we can reduce the collision. And that might be, let's increase the table size as a 8. Table size to 8. Right? Table size to 8. Let's do again the rehashing for these elements. Let's see. I'm not saying definitely it will happen, but definitely there are chances. So like 24 divided by 8. So now position would be 0, 1, 2, 3, 4, 5, 6, 7. So let's see. For 28, it will be 0. So it will go here. 28. Now you can see rehashing 24. Earlier it was at 4th position. Now it is 0th position. Now let's look for 21. This will be 5. So 21 will be here. 22. It would be at 6th position. Then look for 23. I think it would be at 7th position, right? Then look for 20. It would be at 4th position. Let's look for 34. This would be at 2 position. Now you got it. See, we reduced the collision of 34. Understood, Hariharan? See, you can see earlier it was going to collide, but now once we does the rehashing, somehow we are able to reduce it. Somehow we are able to avoid the collision. I'm not saying it will happen every time, but somehow we will be able to reduce it. We apply that mod formula while see we are using divide. So if you remember, Joseph, we have four methods of hash function. We are using the divide one. Consider if 20 and 21 would be at the same index, then need to be do rehashing because one space is empty still. Consider if 20 and 21 would be at same index. No. We will be doing the rehashing with this formula only. Total number of elements, not based on the spaces or anything. We will be doing this on this basis. Total number of elements divide by table size. Total number of elements divide by table size. This is the formula. Based on this, we are going to do the rehashing. Divide by total table size. So total number of elements was there 5, right? 5, and table size was also 5. And we had to take a threshold value for load factor. We have to take threshold value for a load factor, and which is 0.75. Globally, they are using the 0.75 as a value. Correct. So once value of this operation reaches 0.75 or increased to 0.75, we will definitely at that time we will do the collision. We will do the rehashing. So I think in this scenario, after inserting the fourth element, see, let's insert it again and calculate the load factor as well. So first we are inserting 24, which is at this place. So now our collision would be now let's go for 21. So before that, let's calculate the load factor value. It would be 1 divided by 5, correct? Because one element is there and divide by 5, which would be 0.2, which is less than 0.75. So we will not do the rehashing. We'll see. Okay, let's go further. 21 will be assigned here. Again, now for 22, 2 will be here, which will become 0.4. So 22 will be here. Then go for 3. 0.6 will be here. Okay, you're okay. Go for 23 also. Then I think what will come? 22 is done. 23 is done. Yeah. Then I think 34. Let's take the next element, which is okay. I've taken something wrong here. 24 should not come here. 24 should come at this place. Correct. Yeah. So now 4 divided by 5. 4 divided by 5, it will become 0.8. You can see, guys, as we inserted the 23, you can see it has become 0.8. We'll directly do the rehashing here only. Understood? We'll definitely do the rehashing at that place. That would be our formula. Got it, everyone? Yes, number of collision, definitely there are chances that there will be decreasing. Do we not insert at 0? We will not insert at 0. We'll rehash. We'll create a new table. We'll rehash again. We'll not insert it. Or you can insert it. That's fine. You can insert it also. Even if you insert it, you have to you are again doing the rehashing. But yes, it would be better to know. Like, let's see. You can go with both ways. Let's think about it. Do we need to insert it, then do the rehashing? Yes, insert it, then do the rehashing. Because after inserting you will only get the 4. Before that you will not get it, right? Before that it will be 3 only. So after inserting only you will get the 4. So yes, insert it, then do the rehashing. Yes, again the inserting will be done for all the elements which exist here. Rehashing will happen again. Understood, guys? I'm not sure how you're seeing it as a linear probing. It's not a linear probing at all. Linear probing was find out the next element, next available space. We are increasing the size here directly of table. It's not linear probing at all. Guys, in linear probing, in the same table, we were trying to look for the next available space. Correct? But here we are not doing that. Here we have one formula, load factor formula. We are checking that load factor formula after inserting a element. After insertion, we are checking the load factor condition. Once the load factor condition is like increasing, then we are going for the rehashing directly. We have not discussed the linked list approach. We'll discuss after this thing. Or I think if you want one to implement the linked list approach, that would be great, right? If you guys want to implement the linked list approach, that would be great. Yeah. Okay, so guys, let's look into the load factor with the code as well. Yeah. Let's look for the hash factor code. So you guys can see I have taken the max load factor as a 0.75. This is my max condition, which I'm going to take for the load factor. Taking the array table size. So now you can see initially my table size is 5. I'm taking my table size as 5. So array would be size of 5. Then this is the element size, like how many element we have totally inserted. Correct? And load factor is equal to 0. Now, where we are using this thing? Let me take 1 minute. Oh, not needed actually. Not sure why we are taking this thing, but not needed. This thing or not needed. We can calculate it at the runtime only. Okay, guys. So now let's look into the set part. So now while we are inserting a new element, so you can see same logic, same thing will work while we are inserting a new element, table.set. You can see we are first checking is that index exists or not. If that index exists, go do the same thing, find out the key, update it. If that key does not exist, insert the same entries, which we have done already, right? This part already done it in the earlier while we are looking into this. Correct, guys? This part we have already done. The collision one already done, right? I'm not saying that the load factor and rehashing is going to remove the collision. Collision will definitely happen. You can see that's why I have written the collision code first. Guys, now we'll check the load factor. So now you can see first I increases my element size, then I am calculating the load factor. So the total element and total table size. Once it is increasing to the max load factor, I am calling the rehash. And now in the rehash, you can see what I'm doing. First, I have taken my table. Till now, whatever element has been inserted, take that temp table here, create a new array. You can see I created a new array with the double size of table. You can see I'm just doubling it out right now. Table size is 0, 2. And element size has also become 0 because now I'm increasing it again. And then I'm just traversing my temp array and simply calling the set method with the row 0 and row 1. So in at the row 0, we will be getting key, and the row 1, we will be getting value. And then simply running the loop inside the for loop. Because you know that, right? How we are storing it, the data. We are storing data like this, right? ID, comma 1, age, comma 23, and city, comma K. Correct? Then we have another array here, which could have some other data. Then we have another array like that. Correct? Then the larger, this one closing here, this one closing here, this one closing here. And then these are the internal arrays inside this one. So that's why we are doing just passing all the values into the set method again and setting it with the new table size. That's what happening is rehashing. Like after, see, important thing is here understanding the logic. That's what. And after that, all the array operations are happening there. Traversing data, all them like traverse the array and just pass the data there. And there is no change in the get part, no change in the remove part, because those are same. Only this will change in the one extra thing is added here, which is the rehashing and it will only happen based on your load factor. Are we good here, guys? Are we good here? We just need to check, look into the code, guys. Now, load factor will be calculated when, then why 0.775. So see, once you calculate, you have to compare something, right? You have calculated, you have to compare with some value. What is your max load factor? Once you have inserted first element, your load factor would be 1 divided by 5, which means 0.2. You have to compare it with something, right? So that's why we have taken 0.75 is my limit. 0.75 is my upper limit. We can't go beyond it. 0.2 is fine. 0.4 is fine. 0.6 is fine. No need for rehashing. Once we reach 0.75 or more than that, do the rehashing. That's why we have taken the maximum limit there. Understood, Parag? That's why we did. That's 0.75 is the maximum limit. Can it be 0.9? Yes, you can do. You can take any values, but the ideal globally they have suggested to take it as a 0.75, and it should always be less than 1. Okay, guys, are we good here? Joseph, Suraj, Hariharan, Parag. Are we good here with the understanding of logic? Rehashing, did you guys understood the rehashing as well? Any doubt there? Rehashing code part, okay. You want me to code part or logic part? Which one? Code part, okay. See, guys, in the rehashing, what is the step? First, increase the table size. So earlier table size was 5, I increased it to 10. Then I created the new hash table, new array with the new size, because earlier it was 5. Now it has become 10. Correct? Earlier it was 5, now it has become 10. And once we have the new table size, we are traversing the old temp. You can see older hash table we have taken in the temp variable. We are just simply traversing it. We are simply traversing it. While traversing, what we are doing, we are reading all of the key and values, passing it to the set method. Passing it to the set method. So automatically in the new table, this will be set. Automatically in the new table, these values will be set there. And these are some of the condition if temp row, like if and anywhere, if any row does not exist, continue, go for the next thing. These are some like the array methods, like array manipulation is happening. There would be some empty array would be there. So we are doing that. We are checking if at that place we do not have any values, just continue it. Do not go further here to the bottom lines. And these are the columns like these are the array manipulation. So at any index we have multiple arrays, correct? At any index, like at the 2, if you remember this one earlier scenario, yeah, in this 2 we have multiple entries. So for that we are doing this thing. We have taken column as a 0 and we are taking temp row dot length. This is the index 2. At that index, whatever elements are there, go there, fetch the key, fetch the values, and set it to call it the this dot set. Understood? It would set in older index. Why? Why it will set in older index? Your table size has already changed. See, you have Parag. You have changed your hash table here. Your table size is changed. So now hash function will take the latest value, right? While you are setting it, this will take the latest value. Table size and hash table. Got it? It will take the latest size. It will not take the older one. It will not take the older indexes. How you calculate the hash function? Hash function based on the table size. You have already updated the table size. You can see this dot has table size, this dot has table. These values are updated. Now you got it, Parag? This table size are updated now. Your hash function will take the latest value, not the previous one, which was 5. Getting it, guys? Getting this part? Parag, you? See, where is the confusion actually? I didn't understand your question actually. It would sit in the older index. What does it mean? Because how we are getting the indexes? We are getting the indexes based on our hash function. Correct? And hash function, how hash function is generating the indexes? It is generating with the key and the table size. So once the table size has changed, why we will get the older index? We will be getting the newer index, right? Okay, where we set the older values? In the new index, in new size table. In the new index and new size table. Yes. So this is happening in this dot set method, right? This method, this dot set. We are getting the new index here with the help of hash method. Hash method is taking the hash table dot length, which has the new size, as a 10. Earlier it was having the 5. Earlier this hash table as a 5. It was giving the range of index between 0 to 5. Now it has 10. Now we have the new range of index 0 to 9. Happening in the set only. Yeah, that's what. See, every time you are getting indexes with the hash function only. That's what I was trying to explain. In the hash function is depends on your hash table length. So once your hash table length is changed, your index range is also changed. This will place the values, whatever. Yes, this will place all the values which are available in temp. First, that's what we need to do, right? Rehashing means already exist value, rehash them. So whatever values are available, we just need to rehash them with the newer range of indexes. Got it, guys? Everyone, is it clear now? Clear? So in my repo, the linked list code is also there. So if you guys want to see it, I will leave this code to you guys. You guys can later see it, but I want you guys to first implement it and then later on see this code. Okay. Here in the linked list one, I'm also using the max load factor. So also doing the rehashing, everything is there for the linked list scenario. Okay. So you guys can later look into this one. Now let's solve some of the today's problems. Okay. So linked list one, you just look into this one. And then if you guys don't understand, we can talk about it in our next class. Okay. About the linked list one. So, but I want you guys to first implement it with your, try this and solve this with the linked list as well. And I have already visualization I've already given you in the array as we are storing it. Rather than that, we will be taking the linked list for the collision scenarios. Is it okay, guys? Can we move into the today's problems? Everyone? Yeah. So we have already solved these two problems. Let's jump into the third one. Let me see which is anyone without repeating character. Okay. Okay, that's fine. Let's start with the third one only. Okay. So what is the question here, guys? The question is, we have been given an array of integer numbers and a value k. We need to find the total number of continuous sub-arrays whose sum equals to k. Whose sum equal to k. So like this, see, If I take, let me take a bigger example. I have a bigger example for that. 1 minute. Let me go to the third question and let me take the bigger example. Yes, I remember this example I have taken. Oh, I cannot write. Oh, I can write it. Yeah, yeah, yeah. I can. Nice. And k is equal to 5. Okay. Let me take this bigger example to understand this problem, guys. But before that, let me first explain you the problem. Yeah. So 1, comma 2, comma 3. This is one array and they have given k is equal to 3. Right? In the second problem, you can see this second 1 to 3, k is equal to 3. Let me first explain you. So they are saying you need to convert this into sub array. So like 1 will be one sub array, 2 will be one sub array, 3 will be one sub array, 1 comma 2 will be one sub array, 2 comma 3 will be one sub array, and then 1 comma 2 comma 3 will be some sub array. They are saying sum of these sub arrays should be equal to 3. And that's what you need to return. How many sub arrays are there where sum is equal to 3? So how many are there? There are 2. One is this and one is this. So answer is 2. You can see answer is 2. Same for 111. Same for 111. K is equal to 2. So how many sub arrays will be there? Which will give the sum as 2. So 1 comma 1, 1 comma 1. These two and these two. So answer will be 2 here again. I hope you guys have understood the question now. Everyone understood the question? Anyone wants me to repeat it? Understood everyone? Repeat. Okay. So see, Hariharan, we have given one array and they are saying divide this array into sub arrays. Once you have sub arrays, just sum of those sub array should be equal to k. And you need to give us number of those sub arrays where the sum is equal to 3. So you can see in this one sub array, in this one sub array, sum which is matching with 3. In this sub array, 1 comma 2 is 3. That's why answer is 2. In other, you can, if you will sum it, it will become 5, it will become 8, it will become 1, it will become 2. Those are not equal to k. So that's why these two arrays are there. Same here. In this also you can divide it in this way, but there will be only two arrays like this, 1 comma 1, 1 comma 1, which will give you the sum as 2. Now you got it, Hariharan? Got it? Everyone got it? We can move into the solution now. Yes. Okay. Now let's try to solve with this problem. You will understand better with this one. 3, comma 9, comma minus 2, comma 4, comma 1, minus 7, 2, 6, minus 5. I think I need to remove some of the values from here. Because when I was seeing this code, I understood with this problem, with this example. Comma 8, comma minus 3, minus 7, comma 6, comma 2, comma 1. Okay. So guys, you guys just tell me. Okay, yeah, you guys tell me if this is a line which has a distance of y, correct? And if I'm saying this particular distance is y minus k, then automatically this will become k, right? Is it right or not? If my whole line length is y, if I'm saying this much distance is y minus k, then this automatically becomes k, right? Understood? That's the same logic we are going to apply here as well. And here we are going to take our sum as k is equal to 5. So what we'll do, we'll start traversing from the first element. We'll start traversing from the first element and take a sum here, which is y here. Take a sum here. And then we will do the y minus k. Then we'll do the y minus k. So let me do it. So let's start from here. So sum is 3. Correct? I'm here. Sum is 3. So 5 minus 3. 5 minus 3 means y minus k. What will be the 5 minus 3? What will be the 5 minus 3? It will be 2. So I will check in my map. In my map, Does the let's draw the map here only. Let's draw the map here, just parallel to that. Just check in the map, 2 exists or not. Because if the 2 exist before that, then we can simply say 2 plus 3 would be 5. Correct, guys? If 2 exists before 3, then we can say that, this could be one subarray. This could be one subarray. Am I right or not? Everyone understood this thing or not? Correct. We can say if the 2 exists before that, we can say 2 and 3 exist, and then they can make the summary. But 2 does not exist here. So what we will do? We'll simply add this into our map. Let's write only 1 as a frequency. So 1 has already come into our hash map. This is hash map we are creating here. This is a map. Okay. Now let's look for next element. Now let's move from here to the next element. What is the sum now? It is 12. Correct? Now sum has become 12. So 12 minus 5, 7. Does 7 exist in the hash map? Does 7 exist in the hash map? No. So it means it just add the 9 also in the hash map. Whatever we are adding with the frequency I'm telling you here. I'm just writing the frequency here. Does not happen. Does not, like, all the previous element cannot make the sum as 5. Okay, let's move further. Let's move further. So 12 minus 2, it will become 10. So 10 minus 5. If I'm taking all these three elements, so 10 minus 5, 5. Does 5 exist before that? No. So again, just add this minus 2 into our hash map. Correct? Let's go for 4 now. So minus 10, 10, 10, 4, 14. 14 minus 5. 14 minus 5, 9. Does the 9 exist in the array? Does the 9 exist in the map? Does the 9 exist in the map? Yes, it exists. So what will happen? Just go into that array and you can see this would be the place. This would be the array. You can consider it as the 5. You can see. 1 minute, 1 minute. 9 exists in the, yes, I'm doing right. 10 plus 4, 10 plus 14, 14 minus 5 is equal to 9. Yeah, 9 exists. Correct. So after 9 we have to take, right? 1 minute, guys. 9 exists here. Okay. And at that place, 2, it will become 7. 7 and 4, it will become 11. I think I'm doing something mistake here. 1 minute. See, start from 3, sum will be 3. So 3 minus 5 will be minus 2. Correct? 3 minus 5 will be minus 2. Correct? Y minus k. Right? Now let's go for 9. So our sum is 12. So 12 minus 5 is equal to 7. It does not exist. Correct? Now add it, 12 minus 2 is equal to 10. 12 minus 2 is equal to 10. So 10 minus 5 is equal to 5. 5 does not exist. Okay. Then what is next? 10 plus 14. 14 minus 5 is equal to 9. Yes, 9 exists. Okay, 9 exists at this place. So I think that should be our answer, but something is missing, I think. I think after this, it should be our answer. So minus 2 comma 4. We are reaching at this place, right? Minus 2 comma 4. If we will take minus 2 comma 4 as a sub array, we will be getting 2, not 5. Am I missing, guys, anything? How we know the contiguity of the element in the map? It would work for subsets, I guess. Contiguity of the elements in the map, it would work for subset, I guess. No. 1 minute, 1 minute. I think I'm missing something here. 3 comma 9 minus 2 comma 4. I should get the subset here, which should give us the answer, but it's not happening, it looks like. Otherwise, I should not get the 9 there. 14 minus 5 is equal to 9. I would be looking for 9. That's right. And then, one minute, guys. Let me check the code. What I'm missing, I'm missing something there. Yes, sum minus k in the map, adding my count there. Okay. And then if sum in the map, okay, this is the increment part. Okay. Map 0 is equal to 1. I think I'm missing one thing, guys. That's why we are not getting the answer here. 0 as a 1. Ah, okay, okay. What they are saying, what they are doing. Okay, 1 minute, guys. Even if I'm taking 0 as a 1, still. So 5 minus 3 minus 2, okay. And but it is not making the sub array. That's what actually it is confusing me. That is not making the sub array. If I am reaching at this position, my sum is 14 and 14 minus 5 is equal to 9, in which exists in the array, right? So sum minus k in the map. So now count, they are saying make it 1. How? But see, this sub-array is not making that. See, guys, you are able to understand what is happening here? I'm missing something there, which I'm not getting right now. See, okay, by the way, let's look into what are the elements will make the sum as a 5. So 3 comma 9 will definitely not make. If we add 3 comma 9 minus 2, which will definitely not make. So 3 comma 9 minus 2 comma 4. 3 comma 9 comma minus 2 comma 4, 10, and for 14 it will make 14, and 14 minus 5 is equal to 9. So this will definitely not make. What about 9 minus 2? It will 7. 9 minus 2 comma 4. 7 4 11. This will also not make. Okay, guys, I think I will look into this one. But yeah, this is, I think I'm missing something which I'm not getting it right now. So let's not waste more time here. Let's move into the next question. I will look into this one and then again talk about it. But yes, this has to work in the similar way. We have to start from the first index and calculate the sum in each values. And then if we are getting the subtraction of that in the map, we need to count it from there. But something is missing. I'm not sure what is missing. See, if we see the code also, so count start from 0, sum start from 0. We are taking one map and we are assigning map 0th element as a 1. Like we are just assigning first value into the map. It doesn't make any just for 0 scenarios. If somehow a subtraction for any element comes as 0, we will be taking it considering it as a 1. So that's why we are doing the num 0. Even if I'm doing that, so map 0 will be 1, correct? If I'm taking a map, so 0 will become 1. Then let's see the next part. And what I'm doing, I'm just doing the sum. Sum plus equal to nums I. So 3 will come first. Okay, sum is 3, right? Then what I'm doing, 3 minus k. So k is equal to 5, right? K is equal to 5. So 3 minus 5. which is -2, which does not exist. It's not in the map. So what we are doing? If sum in the map sum. Oh yes, that was actually I'm missing. See guys, we do not need to keep this information. We need to keep the sum there. Ah, that's what actually I was missing. See guys, I got it. I got it. Actually, we are setting wrong thing into our map. We do not need to set the individual element. We need to set the sum. We need to because when we are doing 14 minus 5, when we are getting 9, it's the sum. We have already added all these elements. Then we are subtracting it by -5. Correct? We have already added it all these elements. Then we are subtracting. See this one. We are looking for y. So first we are subtracting it. Y minus k. Correct? So that's what we need to keep the. Okay. That's what actually problem was. That's what I'm saying. I was missing a little bit something there. And that was we are setting the wrong value in the map. Now let's see again. Same question. Now I got it. What was we missing? We need to set the map into our sum into the map. Yeah. So let's start from 0 again. Okay, guys. Let's start from 0. Let's start from the first value, which is 3. Okay. So now sum has become 3. So 3 minus 5, which is -2. Correct? So does 5 minus 2 exist in the map? No, map is empty. Map is empty. I am looking for sum, guys, not for the number. Guys, again, I am looking for sum. If anywhere in this array -2 as a sum exists, then we will consider that number. We'll consider that number. We'll consider till there. Okay, but -2 does not exist, so I will take -2 as a 1. First time it is coming. Let's move further. Sorry, we will take the sum, not -1. We'll take the sum, 3. 3 is there. Okay, now let's move further. So 3, 9. 3, 9, these two will make 12. So 12 minus 5 is equal to 7. Does 7 exist in the map? No. So add the 12 there. Can you see, guys? With the values of which we are putting into the map, which will tell us the position. Once we got the 5 anywhere or any number, it means let's move further. Now we are at the -2. So 12 minus 2 will give us 10. Does 10 exist here? No. Let's move further. Let's look for a 4. Yeah. So 14, right? 10 or 14. 14 minus 5 is equal to 9. Is 9 exist in our map? No. So add the sum again. 14 is equal to 1. It means till here we have the 14. Guys, understood? Till here we have the sum as 14. Somehow we are not able to reach the 5 because we are not getting anywhere the sum as 5 here. So that's why we'll keep moving. We'll reach here 1. So our sum will become 15. So 15 minus 1, 15 minus 5, which will be 10. So yes, 10 exists. Yes, 10 exists. So where 10? As the 10 exists, guys, we will be sure that whatever the frequency of 10 is, just take that as a frequency as our count here. And let me show you where we got the 10. We got the 10 at this place, right? We got the 10 at this place. So let's try to add it. Let's try to add these 3 positions. So 4 plus 1, 5, and 19 minus 2, 10. Okay. And yeah, so after this, you can see 4, 1. This is the one set where we got the 10. Just after that, you can see 4, 1. So that would be one subset which is added there, 4, 1. This is the first time we are getting it. Let's move further. There might be more scenarios where we will be getting our answer. So let's move further. So first, but count as equal to 1, we have already got it here, right? Let's move further. We have traversed till here, which was 15, right? 15, yeah, set it. 15 also set it. 15 as 1. No, no, yeah, 15 was 1, correct. That's what we are doing, right? Let me see. Yeah, we are setting the sum only, correct. So now let's move here into this one. So 15 minus 7 will become uh, 8, right? Till here, whole addition is 8. Just do it again. 12, 10, 14, 15 minus 7, 8. So 8 minus 5 is equal to 3. 8 minus 5 is equal to 3. 3 exists? Yes, 3 exists. So after this, after 3, just add all the element. After 3, just add all the element. First increase the count to 2. Let's add it. So 9 minus 2 will become 7. 7 plus 4 will become 11. 11 plus 1 will become 12. 12 minus 7 will become 5. So guys, this is the second array which we got. Now, are you able to understand the logic, how the logic is working? We just need to add the sum and keep it into our map. So that sum will give us the whatever element we have added till now. And then see, last one is this one, right? The minus 7 you are saying? Last 7 is the minus 7, right? So you just need to add all these elements. All these elements till minus 7. Add it. So 3 plus 9 is 12. Minus 2 is 10. 4, 14. 1, 15. Minus 7 will become 8. So once we reach till here, total sum is 8 of this sub-array. Of this sub-array, total sum is 8. Total sum is 8. So what I did, 8 minus 5. 8 minus 5 is equal to 8 minus 5 is equal to 3. I find it out. Does 3 exist anywhere? Yes, 3 exists. So wherever 3 exists, just after that, take it all the elements. And that elements will be definitely make our sum as 5. Definitely will make our sum as 5. See guys, this is the same. This one. This is total y, which is 8. Which is 8. And then what we did, we find it out y minus k, which was 8 minus 5, 3. So first once we find it out y minus k, it means automatically the remaining one will become k, which is 5. So that's what happening here. This 3 is y minus k. And this k is 5 already there. And we have total sum as 8. So we are storing these sum there. And then we are calculating y minus k. If y minus k exists, it means after that y minus k will be our k value. Now you guys able to visualize it, how this code is working with this example. I also understood with this example only, but I forget in early about the setting the map value. Got it, guys? See, this was very easy questions, but I just forget about the what to set in the map. So that's why actually I got the confused there. But now if you have to move further, and again, once you will move further, you will again got the new value of y. Again, you need to find out the y minus k. Once you find the y minus k, which is equal to, and that y minus k exists in the map, you just need to look for the next element. Anyone has any doubt? Anyone wants me to repeat it? Or we can go into the code? Vishal, you want me to repeat it? Okay, sure. So Vishal, what I'm doing first, let's understand this thing. I think this part, the line part. Because once you will understood this line part, then you will understand this logic as well. Okay, so see Vishal, if this line has a length of 12, okay, and we have been given one value as a 5, correct? And in this line, there are different values, right? Like there would be 3 would be there, there would be 2 would be there, there would be 2, one more 2 will be there. there would be one more 2 will be there, and then there would be, or we can say it directly, we can take 4 here or 5. Okay, correct. These are the 4 values, 4 points which has given the total values as a 12. Correct. This is 3, this is 2, this is 2, and the remaining one is 5. We can divide, like we can say that this distance is 1 minute. This whole distance is 5. This whole distance is 2. That's how I was trying to represent this. This whole distance is 2. And this the remaining distance which is start from here, which is 3. Okay? Let's remove these points. Okay? Okay, Vishal? Did you understood this lining part? This whole distance is 3. This whole distance is 2. This whole distance is 2, and this, and the total distance will be 12. Correct? Okay. Now we need to find it out that in this whole distance, does 5 exist or not? Like, is there any distance where we will add 2 of the distance? Can we get the 5 or not? So what I did in my questions, I was just looking for 12 minus 5. 12 minus 5, which would be 7. So I would be looking here in while adding these all elements, does 7 exist anywhere? Does 7 exist anywhere in my sum? So see, while I'm representing them in the map, while I'm representing them in the map, I'm just keeping their sum of it. So like once I am traversing this one, so I just taken the sum as 3, 3 as 1. Okay. Then I went for this element 2, which is sum is 5. So I kept it 1 here also. Then I went for here. Then I sit for 7. Yes, 7 is, yeah, 7 is there. Correct. And then I went for this one also. And then I'm looking for 12. So 12 minus 5 is equal to 7. Does 7 exist? Yes, it exists. And 7 exists. So it means there is one possibility that I can get 5 easily. There is one possibility in the before arrays that somewhere that 5 exists. So if I talk about this is 3, this is 5, this is 7. Till now we got the 7. So after this element will be returning us 5 directly. This element will be returning us 5 directly. Understood, Vishal? This element will be returning us 5 here. That the whole 5 is there. So that's what the same logic I'm applying here as well. The same logic I'm applying here as well. I'm starting with 3, the first element. I'm starting with 3 here, and then looking for that 3 minus 5. If the minus 2 exists, no, minus 2 does not exist. So just add the sum as 1 here. Then I went for this thing 3 plus 9, which is 12. 12 minus 5. Does 7 exist earlier? Any of the any of the previous sum is equal to 7? No. We look into the map. There is no 7. So that's why, okay, let's fine. Let's move further. 3 plus 9 minus 2. Now the new sum which we got after adding 3 elements, which is 10. So 10 minus 5, 5. Is there any sum of the previous elements which is equal to 5? It's not. So then what we'll do? We'll move further. Understood, guys? So that's what same thing is happening in code as well. You see, this is the count, this is the sum. We have map here. I'm slicing my 0 as a map, but it's not needed, by the way. It's just for the scenarios when you do not have any elements in your numbers. That's for that is for that scenario only. And then you can see here directly, I'm just adding my sum, checking into the map. If it exists, I'm just increasing my count with the value of map. And then you can see in the sum in the map, if it exists, just increasing the value of it. If not, just assigning the value of 1. Okay, let's run this dry run. Let's run this whole code again, which will be, let's dry run it again. Okay. Let's dry run it again. No problem. Okay, so let's start from 3. And here it will be our map. Here will be our table, we can say. Okay, here will be the key, here will be the value. Correct? And we are going to keep the sum. Wherever we are traversing, we are going to keep the sum. So let's start from 3. And we are, every time we are going to see sum minus k. Sum minus k. Okay, guys, till now are we okay? Sum minus k. Till now are we okay? Anyone has any doubt here? If we need sum of what the elemented indices 1 and 2 give, how do we check it? Are we storing it? No, we are not storing that. We are just looking here for the count part. We are not storing that part. For that, we might need some other data structure as well. But here they are simply asking us the count of it. Here they are just simply asking for the count of it. If they are asking us about give us the element as well, we might be using one window. We might be using one window which is telling us start index and the end index. Understood, Vishal? If somebody is asking you in the same question, if somebody is asking you about the elements as well, you have to take two pointers. One pointer is already iterating it. You have to take one more pointer. That pointer will be at the starting position. Correct? There is one question actually where you are going to tell the elements as well. There is one question, and that place you need to take the array. You have to take the window, and that window you will slide it, and that window will tell you the starting and ending position of the sub array which is fulfilling the condition. Okay, so Hariharan, let's understand. So let's start from 3. What we need to do, guys? We need to add these elements, and somehow our sum should be equal to 5. That was the question. Correct? So let's start from 3. So 3, and then what we are doing? 3 minus 5 is equal to minus 2. Does any of the earlier sum in our map table has minus 2 or not? It's not, right? It does not exist there. So what we'll do? We'll add our sum with the value 1. Did you guys understood this thing? 3, 1, right? Because minus 2 does not exist earlier. So let's move further. Let's look for 9. 3 plus 9, which is 12. So 12 minus 5, which is 7. Does 7 exist? Does 7 exist earlier? Right? There is no element in the map. There is no sum in the map which has been equal to 7. So it means we need to put our element directly here, which is 12, and keep the frequency as 1 there. Correct? We are just keeping our sum there. Now let's look for next element, which is this one. 12 minus 2, which is 10, minus 5, sum minus k. Does 5 exist in the map? Is there 5 exist in the map? No. So just keep the 10 as 1 there. Correct, guys? Are we doing correct till now? 10 minus 5, we have checked that. It's in the sum map array, it does not exist. Okay. Then look for 4. 10 plus 4, which is 14. 14 minus 5, which is 9. Does 9 exist in the map? No, it does not. Then 14 also will be added there. Are we good till now, guys? Are we good till now? Yes. So now let's look for next element, which is 1. So 14 plus 1 is equal to 15. So 15 minus 1 is equal to 10. Does 10 exist? Yes, 10 exists. So it means the between this 10 sum and between the 15, whatever elements are coming between the sum 10 and between the 15, whatever elements are coming, that will make our answer 5. So let's look into that. Where 10 was coming? 10 was coming after adding third index, after adding third element. So this was the third index, right? So after that, whatever elements are coming, those will be make our sum as a 5. So you can see 4 comma 5. After that, 4 and 1 was coming, and these two will make our element as a 5. Now you got it, guys. Little bit understood. Joseph, Arad, Suraj, did you guys understood this now? Are you guys still there? You guys are not there? Okay. Okay, let's move further then. So minus 7. So 15 minus 7 is equal to 8. Does it exist here? 8 in the map key? No, it does not. By the way, we have not added the 15 here. So add the 15 also. Now, yeah. So we are looking for the 7. So 8 does not exist. So let's keep it like that. Sorry. 15 minus 7, 8. 8 minus 5 is equal to 3. Sorry. We just taken the 15 minus 7. 8 minus 5, 3. Yes, 3 exists. 3 exists. It means between 3 and the 15, between 3 or 8, sorry, between 3 and 8, whatever element exists, they are going to make the solution. So you can check that. Between 3 and 8, these are the elements which exist. 9, minus 2, 4, 5, minus 7. Yes, these are the elements which exist. So if you add them, you will see 9 minus 2, 7, 7 plus 4, 11, 11 plus 1, 12, 12 minus 7 is equal to 5. So we are seeing the 5 answer. So we'll make count is equal to 2. Correct? And we will add 8 here. Let's move further. 8 plus 2 is equal to 10. 10 minus 5 is equal to 5. Is 5 exist in the sum? No. So add the 10 here. So see guys, already 10 exists. Already 10 exists. So we will replace this value with 2. We'll replace this value with 2. Okay. Now let's move further. What was the sum? 10. Yeah. So 10 plus 6 is equal to 16. Minus 5 is equal to 11. Does 11 exist here? No. So we'll add the 11 here. Sorry, we'll add the 16 here. We are adding the sum here, right? So till now 16 is done. So now let's go for 16 minus 5, which is 11. 11 minus 5 is equal to 6. Does 6 exist? No. So add the 11 as so. 11 as 1. Correct? Let's move further. Let's go for 8. Do the same. 11 plus 8, which is equal to 9. 19. 19 minus 5 is equal to 14. Does 14 exist? Yes, it exists. Where we got the 14? We got the 14 at this place. Correct? Let's add it. 14, yeah. So between 14 and this 19, all the element will make your answer 5. So let's check it. Check that. So 1 minus 7 will become minus 6. Plus 2 will become minus 4. And plus 6 will become plus 2. And then minus 5 will become minus 3, and 8 minus 3 will become 5. So yes, this particular group will also make your answer as a 5. So count will become 3, and then we will add the 19 also here as a 1. Correct? Let's move further. 19 minus 3. Let's erase it. So 19 minus, what was the next element? 3, which will make 16. 16 minus 5, 11. Does 11 exist? Yes, 11 exists. Again, where we got the 11? I think we got the 11 here only, at the minus 5 place. So we can check that. 8 minus 3 will become 5. So yes, this is again one subset, which is going to make to answer. So 3 will become 4. That's how, guys, this is going continuously. Sir, line number 30 to 35 are get and set in map. 30 and 35. 30 and 35. Yes. They are get and set. They have taken an object, right? So that's why they are doing the object way. They are not taking the map. So that's why they are doing in this way, in the object. Yeah. I hope, guys, you guys have understood now the logic. Anyone still has any doubt? See, which part is not clear? So we are checking if some in the map, if some exists in the map, get the value of that map and increment it. In earlier we were doing map.has, but here we are doing sum in map. That is because why we are able to use the in here, because we are using the object. So in object we can use it, and then you can see we are not setting it. We are doing map sum is equal to 1. Okay. Parag, you still didn't get it? Where you got stuck? Got it. Okay. What about others? What about others? Ekta was there. Arad was there. Where you guys went? Okay. You guys are still here. What about others? Did you guys understood? Nayan. I think Nayan has just joined. So remaining question, I would say to you guys, go and try for it, because these questions are, I think, going to be similar logic. The remaining two questions are going to be similar logic. We just try to think about these questions. These are very interesting questions, and I'm telling you, all of the questions are going to be taking the single complexity. Like it would be not be n square, it will be n everywhere for all the remaining problems which are mentioned in the slide. Yes. Okay, guys. So that's all from today. I think you guys have whole Saturday, whole Sunday, half of Monday as well. So you guys have a lot of time. So let's first start with the hash table implementation in linked list, and share your code in the LinkedIn so I can see that whatever you guys have implemented. And then let's try to solve these remaining. I think 2 problems will be there, and then there will be 2 problem in assignment. So 4 problems are remaining. Let's try to solve those 4 problems. Okay, guys. So that's all from today. I know the last question got little bit here and there, but yes, that question was really not tough. I will say you. I just missed the last part. That's why actually it looks like that little bit tough, but that was not tough. Okay, guys. So let's practice it. Then we'll talk it again on I think Monday. Yeah. And wherever you guys is stuck, we'll try to answer that again. If you want me to like talk about the same question again on Monday, I will definitely do that. Okay, guys. So let's have a nice weekend and let's meet back on Monday. Okay, guys. Bye bye.